when you charge a capacitor through a resistor, it doesn't charge instantly. It takes some period of time or duration in time to charge up. Likewise, when you discharge a capacitor through a resistor, it doesn't discharge instantly. It takes some time, some duration for that charge to disappear. The equations that describe the charging up of a capacitor through a resistor or the discharging of a capacitor through a resistor involve an exponential function. And they also involve a time constant, which is the characteristic time for the charging or the discharging of the capacitor. And that time constant, in both cases of charging, discharging, is given by RC, the product of the capacitance of the capacitor, the resistance of the resistor. In this question, we're asked to figure out the dimensions or the units of RC. It's interesting that the dimensions or units of RC are times, seconds, but it doesn't really look like, when I think of RC, that the dimensions, units of RC would be time, but we're going to show they are. So the way we're going to do that is to fill in the dimensions of resistance and fill in the dimensions of capacitance. I'm not going to put in the dimensions of resistance in ohms. That doesn't help us too much. I'm not going to put in the dimensions of capacitance in farads. That doesn't help us too much. The dimensions of tau are ohms times farads, but that doesn't allow us to see that an ohm times a farad actually has a dimension of units of time. The way I'm going to fill in the dimensions is in terms of other quantities based on two, very familiar equations to us. One of them is Ohm's law, and let me write it in a form that is Ohm's law for the resistance of a resistor would be the voltage across the resistor divided by the current through the resistor. And the other equation, another very familiar equation to us, is for capacitance. The capacitance of a capacitor is the charge that's stored on the capacitor divided by the voltage that's applied across the capacitor. And so I'm writing these two ingredients, resistance and capacitance here, in terms of sort of fundamental quantities of electricity, voltages, charges, currents. And we're going to use those fundamental relationships between resistance and capacitance of circuit elements and the voltage, the current, the charge to write the units of resistance and capacitance. So we can write the units of resistance as volts divided by the units of current, which is amps, or amps are coulombs per second. And we can write the units of capacitance as the units of charge, coulombs, divided by the units of potential difference, that's volts. And so I've used these master equations, Ohm's law, capacitance equation, to remind me of the units of resistance and capacitance in terms of rather fundamental quantities, the potentials, the charges, and so on. Notice that when I'm writing units, when I write dimensions, I'm putting these square brackets around the units, or I could put square brackets around the dimensions to know that I'm thinking about the dimensions, thinking about the units. Now, to find the units of the time constant, which is RC, all I've got to do is multiply the units of resistance by the units of capacitance. So let me go ahead and fill in the units of resistance and capacitance. Then we'll do the multiplication. When I fill them in, I'm going to rewrite the units of resistance in this fashion here. We had, for the units of resistance, the units volts divided by the units of coulombs per second. I can rewrite that as the units of volts times the units of seconds divided by the units of charge coulombs. And then I can multiply this by the units of capacitance. That's coulombs, the units of charge, divided by volts, the units of potential. And you see here immediately why I rewrote the units of resistance in this slightly different fashion. Because here it becomes completely obvious, right, that the units of charge in the denominator of resistance cancel with the units of charge in the numerator of capacitance. The units of voltage in the denominator of capacitance cancel with the units of voltage in the numerator of resistance. And we're just left behind with the units of time, seconds. And so we indeed find, maybe surprisingly, that RC, the product of resistance and capacitance, does have the units of time. It does have the dimensions of time. RC is a characteristic time, is the characteristic time to charge up, to discharge the capacitor.